Hello everybody, today we're going to be talking about the queuing diagram. This diagram measures the arrivals compared to the departures. And these are measured on the y-axis, typically in the number of vehicles. And it's also measured with time, as increasing in minutes as you go from left to right. So in this diagram, queues are the vertical displacements between the two curves, and delays are the horizontal displacement between the two curves. For some key points you have to look out for are the maximum queue, which happens at this place right here, and the maximum delay, which happens at this place. And also, the total delay is just the area between the two curves. And sometimes you are supposed to find the time at which the departures and arrivals are the same, which dissipates all the queues. And those points are found right here, and you find them by setting two equations equal to each other. Like, for example, the equation of this line and the equation of this line, and this intersection is where the queue dissipates. So after talking about this, let's move on to an example. Okay, in this example, we are given a situation where the arrivals arrive at 30 vehicles per minute. And for the first 15 minutes, the departures are 15 vehicles per minute. And because of an accident, so there was a lot slower departure time. But after 15 minutes, the solution got resolved and the departure increased to 45 vehicles per minute. And we are supposed to find the time for the queue to dissipate, which is this time right here, the maximum queue length, the maximum delay, and also the total delay. So first, let's solve for the time for the queue to dissipate. So that is also equal to this point right here, where this equation is equal to this equation. So setting it up, 30t is equal to, and since we are starting from this line, we first have to figure out what elevation this point is to use it in the equation. And doing that, we can just see that it's 15 times the 15, since that is the point from the first line. And we add 45, because that is the slope of this, times t. But since t is 15 minutes after the initial time, we would write t minus 15. And simplifying this equation by collecting like terms, distributing this out, we get that t is equal to 30 minutes. And then again, this is the time for the queue to dissipate. Now let's solve for the queue maximum, which occurs at the largest vertical displacement, which happens at this point. So to find this, all we would do is subtract this point minus this point. And since we already calculated this point, we just have to calculate the top point, which is just 30 times 15. So 30 times 15 minus the value of this, which is 15 times 15, or just 225. And simplifying this, we would get an answer of 225 vehicles. And then again, this is our queue maximum. After solving for the queue maximum, now we solve for the maximum delay. And to do this, we would just subtract this time minus this time, since at this point is where the maximum horizontal displacement occurs. And since we already know that this value is 15, we just have to find the value of t, where a is at this point. So to do this, all we have to do is set this horizontal displacement, which is, since we already calculated earlier, it's 15 times 15, which is 225. So delay maximum is just 225 is equal to 30t. And to solve for t, we get 7.5 minutes. And this is the maximum delay. And as you can see, my graph isn't quite to scale, but no one's perfect. So after solving for the maximum delay, now we solve for the total delay, which is just the area between the two curves. And if you notice, these two triangles are similar. They're equal and both have a width of 15 and a base of 225. So we'll just assume this middle piece is the base and just solve for one of the areas of the triangles and multiply by 2. So the delay total is just 2 times the area of a triangle, which is 1/2 base. But as I said earlier, we'll just assume this middle part is base, just for simplifying stuff. And that's 225, since we found that the difference between this value and this value was 225 in the previous step, multiplied by the height. But we would just assume the height is going in the horizontal direction, which is 15. So simplifying this, we would get, and as you can see, the 2's would cancel out, so it would be 225 times 15, which is 3,375. And these are vehicle minutes, because as you can see, the 225 are vehicles and 15 is minutes. And that is the total delay.